Show that the cross product of a and b squared is equal to the magnitude of a squared times the magnitude of b squared minus the dot product of a and b squared for any vectors a and b. Okay, so first thing we're going to note is that if vectors a and b, that a and b are vectors, and theta is the angle between them. So if you take a look at here, this first definition for the cross product of a and b is equal to the magnitude of a times the magnitude of b times sine theta. Also, the dot product, the definition for this is the magnitude of a times the magnitude of b times cosine theta. So from this, we can extrapolate that we replace the cross product definition with a times the cross product of a and b squared with the magnitude of a times the magnitude of b sine theta. So we'll get magnitude of a squared times magnitude of b squared. Excuse my handwriting. Writing with the mouse is a bit difficult. And we get sine squared theta is equal to magnitude of a squared times magnitude of b squared minus magnitude of a squared and b squared once again times cosine theta. So if we take a look at our new equation by just simply replacing the cross product of a and b squared and the dot product of a and b squared with the cosine and sine definitions, we get this new equation right here. And from this equation, we could take a look at just the right side and see that over here on magnitude of a squared and magnitude of b squared, we have it on both sides of the subtraction sign. So we can actually factor out the magnitude of a squared and the magnitude of b squared from this side of the equation. So this will leave us with magnitude of a squared and magnitude of b squared times 1 minus cosine theta. And on the left side of the equation, we still have magnitude of a squared times magnitude of b squared sine squared theta. Now, if we look at both sides of the equation, we notice that magnitude of a squared and magnitude of b squared are present on both sides of the equation. So what we can really do is divide magnitude of a squared and b squared from both sides of them, and that'll leave us with just sine squared theta is equal to 1 minus, sorry, I forgot to put the cosine square over here, cosine squared theta. Now, if you take a look at our final equation right here, you'll notice it looks really similar to the Pythagorean identity of sine squared plus cosine squared is equal to 1. So really, from doing this substitution of the definitions of the cross product and the dot product, we find that by looking at our original equation, we're left with sine squared theta is equal to 1 minus cosine squared theta, which is just another way of writing sine squared theta plus cosine squared theta is equal to 1, which thus leads us to believe that for any vectors a and b, this equation holds true. Now on to part B, we'll ask, well, if the dot product of a and b is equal to square root of 3, and the cross product of a and b is equal to this vector coordinates of 1, 2, and 2, then let's find the angle between vectors a and b. So taking our definitions that we wrote earlier up here, we know that, okay, well, the dot product of A and B is the same as magnitude of A and B cosine theta. So we'll just write that as square root of 3, like it says in our problem. And then we know the definition of the cross product and note that as, okay, well, we have our vector coordinates, so let's plug in each of them for x, y, and z into our cross product, the magnitude of our cross product. So we take the square root of each of those coordinates, square them, and add them together. We're left with square root of 9, which is also 3. And to find the angle between vectors A and B, we can say, well, okay, the vectors between A and B are shown as, between our dot and our cross product, as sine and cosine. And tangent happens to be equal to sine theta over cosine theta. So really we'll just take our value used from the dot product and the cross product and plug them in for sine and cosine. So we're left with tangent of 3 over root 3. But we don't want to just find tangent. We want to find specifically theta to get the degree of the angle between vectors A and B. So in order to do that, we simply we have to leave theta by itself and take the inverse tangent of 3 over root 3. So it's shown as theta is equal to inverse tangent of 3 over root 3. And if we plug this into our scientific calculator, we'll see that this is equal to 60 degrees, which is the angle between vectors A and B.